For the half angle identities, cosine of x equaling 2/5 here, and you know that x is between 3 pi over 2 and 2 pi, so it's in the fourth quadrant. I draw a picture of this, but it's really not necessary because one of the things, I mean, I might want to keep note of what quadrant it's in, but I'm going to use the inequality a little bit more for this. Along with that, if you look at the formulas we have for the half angle identities, the cosine of x is usually what I need to make use of. So I already have the one thing I need to have. Now, if they told us that the sine of x equaled something or the tangent of x equaled something, then I would probably use that to figure out what the cosine of x is and use that to come up with my, to work with my half angle identities. But as I had mentioned before, those formulas, if you notice for the half angle identities for sine and cosine particularly, I see that plus or minus symbol in front of that square root. Again, that doesn't mean I'm going to use both. So if you give me an answer when you're using a half angle identity and you are showing a plus or minus symbol, you're not correct. That plus or minus symbol for those half angle identities means that you have to choose which one it is. And here's how I make that choice. If I note that x is between 3 pi over 2 and 2 pi, if I take half of x and I take half of the two ends, that means that x over 2 should be somewhere between 3 pi over 4, which is also known as 135 degrees, and pi, which is 180. So that would put x over 2 somewhere in quadrant 2. In quadrant 2, sines are positive, cosines and tangents are negative. So I had to keep that in mind because that'll help me choose whether I'm using the positive square root of the formula I have or the negative square root of that formula. I show here that I found like the other side of this, but really you're going to notice I'm not going to really use it for any calculations because I don't need to know what the sine of x is for this. The cosine of x is sufficient. So the sine of x over 2 is going to be the positive square root of 1 minus the cosine of x, which is 2/5 over 2. And if I carry that out, I get the square root of 3/10. Now, if you leave it as a square root of 3/10, or if you do square root 0.3, that's suitable for me. That's also suitable for what oftentimes web work would expect of you. Just be aware that typical textbooks won't like that because if I take the square root of a fraction, then technically I still have the denominator being square rooted. That's a big no-no in a lot of math textbooks. So they'll tend to rationalize the denominator. As you see there, I could rewrite that as a square root of 3 over the square root of 10, and that would multiply the top and bottom by the square root of 10 to rationalize that denominator. So the square root of 30 over 10 is the most common way that a textbook would probably present that answer. And any test bank or multiple choice items might be drawn from might present it that way as well. So the cosine of x over 2, I'm going to do the opposite of the square root of 1 plus the cosine of x over 2. In this case, cosine of x is still 2/5. So I'm choosing that negative sign because I know cosine of x over 2 being in quadrant 2 is going to be negative. So I would get negative the square root of 7 over 10 when I carry through all that math. And again, I show the rationalization of the denominator. Although down here, there's an extra negative sign that really shouldn't be there. So I would get negative square root 70 over 10, which is the way a textbook or a multiple choice item may list it. Now at this point again, I can either use one of the formulas I have for the tangent of x over 2, if I want to. Or I could use the fact that, the tangent of x over 2 would be the sine of x over 2 over the cosine of x over 2. Which, if I've already resolved the positive and negative issues of sine and cosine, I don't have to worry about making choices about what tangent should be. Although I should keep in mind that tangent should be negative as well, and it ends up being negative. And you see all the work there. I end up with the negative square root of 30 over square root 70. Which would basically reduce down to negative square root 3 over square root 7. If I rationalize the denominator, I would get negative square root 21 over 7. So oftentimes this sort of work over here, this work that I see right here, would have to be done in order for you to pick which quadrant x over 2 is going to be, so you make the right choices for the positiveness or negativeness of these trig functions in the long run. So keep that in mind. Do not leave the plus or minus symbol in for using these identities because that would be incorrect. Sometimes they make it more simplistic. They say find the sine of pi over 8. Now, if they ask you to find the sine of this, and sometimes they'll say find the exact values, or they'll even preface do not use a calculator, that sort of thing, then you know it should be related to a, one of the special angles that you're asked to know the trig functions for. And if I look at this carefully, the sine of pi over 8 is the same thing as me taking pi over 4 and dividing by 2. So I could use a half angle identity for this. And I'm going to use the formula sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2, which is essentially the half angle identity formula again, except I'm using theta here instead of x, doesn't matter. Now here theta is going to be pi over 4, okay? Not pi over 8. It should be, whatever I'm using for theta, if I'm using like special angles, it should be an angle that I know the cosine for. So I also know that pi over 8, if I'm taking half of 45 degrees, it's about 22.5 degrees. I know it's going to be in the first quadrant, so when I use the formula, I'm going to choose the positive square root. I'm not going to choose the negative symbol. So that's going to equal the square root of 1 minus the square root of 2 over 2, because square root of 2 over 2 is the cosine of pi over 4, all over 2. I certainly do not like having a fraction with fractions in it, so I'm going to carry through some work to, get a single fraction. I'm going to still keep it exact, and I have to also keep in mind that I usually don't want a square root on the denominator, but if I square root that 4 in the denominator, I do get 2. So the final answer ends up being the square root of 2 minus square root 2 all over 2. And that's a very typical formula. We've actually seen that formula before, and before we used half angle identities, we kind of used other methods of determining what this angle would be in other examples previously done. So